think we can start. Hello, good morning. Thanks that you're here for my talk about 3 common pitfalls, and obviously also about how to avoid to get into these pitfalls in microservice integration. And I'm basically, for myself, I'm traveling a lot, either on conferences, writing articles, and these kind of things, but I'm also doing a lot of proof of concepts, doing a lot of solution architecture workshops at customers, actually. And that's where I see a lot of things customers are currently adopting or problems customers are currently having. We have customers through all industries, like whatever, like Lufthansa or Zalando or Allianz or whatever. And throughout that, doing that job, I saw a couple of patterns emerging over the last years. And the most obvious one is actually that a lot of things get distributed nowadays. So a quick poll, actually. Who is doing microservices? Quite a lot. OK, awesome. Who is doing serverless function as a service? A few already. Who is doing at least one REST call or SOAP call in the architecture? Okay, so we're covered. And that's actually, I could have named the talk that as well. I mean, it's basically about distributed systems. So microservices is the current buzzword, which is good to hook up with. But it's actually about distributed systems. And I normally use that metaphor for distributed systems, so that I learned that from Jonas Bonnet, the Lightband guy, the Akka guy. And I like that very much, actually. So we have that. Like the small hut here, that's your microservice, that's your Java program. That's a relatively nice place to be. There you can program, you know what threading is going on, you have probably asset transaction management, and it's nice and cozy in there. There's a heating and so on and so forth. But whenever you open the door, then you meet the network, the rough ocean, and there a lot of strange, weird things will happen. You probably are familiar with the fallacies of distributed computing. That's from Peter Deutsch. You can look it up on Wikipedia. It's quite common. And the first fallacy is the network is reliable. It's obviously not. I mean, everybody using Wi-Fi from time to time knows networks are not reliable. They fail. And then strange things will happen. And that's what we have to adapt with. And I see that at a lot of customers. And sometime last year, I started to write that article for InfoWorld. So you can basically read it back afterwards in that article. So a lot of the stuff I'm talking about today is also written down on InfoWorld. And I basically boiled it down to 3 challenges. Actually, you could do whatever, 37 challenges if you like. I mean, you always have to boil it down to some. And these are common challenges I see. So that's my personal, obviously biased worldview, but I think it's helpful for a lot of products. And it's about communication. That's where we start with, about asynchronicity, and my favorite topic actually about consistency in these kind of systems, distributed transactions. So let's go into that. And one of the things, and that's an interesting observation, it's not very radical, and most people start to get used to it. But one thing we really have to accept with these distributed systems we're building is that some parts are always broken. It might be the network, it might be some resources, might be the service itself, but it will be at some point in time broken. That's normal. That's something we have to deal with. But what we have to basically to make sure is that this doesn't really tear down the whole system, that leads to cascading failures tearing down everything. And that's actually what we want to avoid. And that's a very important thing. And that's can start actually very easy. And I'm an example guy, so I want to dive into an example, dive into code as quickly as possible. And do a very easy example here. So I'm assuming that you want to retrieve some payment, so you have a payment microservice. And that probably, if you want to provide credit card payment, uses an upstream credit card service. So that could be whatever, probably even provided in the internet, like Stripe or whatever. So that's a hosted service. You just leverage that, and you use a REST API. That's a scenario you want to look at. And that's not that uncommon, actually. And I do it because we're at JAX, so I'm doing it in Java, and I'm using Spring Boot in that case. Who's using Spring Boot, just out of curiosity? Wow, that's a lot. Who's using something other like Wildfly or WebSphere or what is the else? Tomcat? Ooh, not Java? I still wonder what the rest is doing, but it seems to be Spring Boot is the thing. That's good, actually. Then it's easy to follow the example. So let's get going. All the code I showed today is on GitHub, so you can look it up and play around with it yourself later on. And I switched to my IDE. The first question I get is that Eclipse? Yes, it's still Eclipse. I use Eclipse for that, and it's okay for me. It works. but it doesn't matter actually. So we want to look at the code. This is the code. Is that readable in the back? Yeah, okay, awesome. So I have a REST controller. That's a Spring way of providing a REST API. So I'm in the payment service. I want to provide that functionality to retrieve payments. So I offer, in this case, a put method. You can discuss for ages about the naming and what kind of method here, but that doesn't matter actually. I provide that, doing some nonsense stuff for data, and then I do the real thing. I charge the upstream credit card service, and if I'm in Spring Boot, it would be it's quite normal that I use the so-called REST template from Spring. There I can do a post to a certain URL, which I probably retrieve from a service registry. Then I send over a request, which I prepare here, and then this is transformed to JSON automatically. I get back a JSON, and this is transformed to a Java POJO again, and then I can read data from the response. Who has programmed something like this before? More or less, yes. Okay, awesome. So you know what I'm talking about. Let's look at that. So what I have here is I have the payment service running. Yeah, not that interesting to read anyway. It's a console window, so awesome. And I have the Stripe, I called it a fake service running. So that's a second Spring Boot application, which basically emulates there as the real Stripe service. Okay, so I have, that's my upstream service, that's my payment service, and I can do REST calls. So I can call that service with a put method. I send it. What happens is that we charge the credit card, get back, and this is done. Okay, woohoo! That was awesome, right? So that's what you probably already know. Now I want to do something with the Stripe service. I can change it to behave slow. So probably the more realistic scenario would be that the network is slow, right? So you call and the network is some kind of slow. What happens when I push this send button? That's a test question if you're with me. It's an easy to answer question. It takes long, yeah. So this is a random delay. It takes 32 seconds. What we can see, it's blocking, it's blocking, it's blocking, and it will be blocking for these 32 seconds, right? And that's bad. That's actually pretty bad. Why is that so bad? Because if I look back, and that's exactly this. But what we did is that we had that upstream credit card service, and we have the payment service. And now the credit card service misbehaves, or the network misbehaves. And now we're blocking all the threads from the thread pool in the payment service, and that means the payment service will be unresponsive soon. So that's bad. You shouldn't do that, right? How can I avoid that? Any ideas? Make asynchronous, that will be one thing. I come back to that later. What's the typical pattern I could use here? Anybody heard of a circuit breaker? Yeah, awesome. Circuit breakers, that's one of the most actually basic patterns here, which you should use. That's a basic pattern. It's surprising that still a couple of people don't know, but that's good. If you learned something about circuit breakers today, that was already worth it. So the thing is very easy. The code is basically the same. I charge the credit card. The only thing I did is I use Hystrix. Hystrix is from Netflix, open source library for circuit breaking. And that's one way of doing it. I just nest that code I have into the Hystrix command. And then it works like the circuit breaker in your house. So if something is strange with the electricity, before everything burns down, it just switches it off. And then it doesn't even try to connect to the credit card service anymore, but raises an exception immediately. And then what Hystrix can do, it can check, okay, periodically, if the service is alive again, it will automatically switch back on. Okay, that's a circuit breaker. In Spring Boot, you could use an annotation on the method. It can be used very easy. If you're in microservices, probably you heard about service messages like Istio or Linkerd. They can do circuit breaking for you. So that's a very basic pattern, important to know. How does that look? Very easy. Quickly calling v2. The credit card service is still slow, so it takes 22 seconds. Not sure if you can read it in the back, but it takes 22 seconds. But I get an error very fast. Right? That's the idea. No, I'm not blocking the payment service. And that's important. That's an important basic thing. My observation is circuit breakers are kind of known. Not to everybody, but they start to be known. And that's often known as fail fast. So that's a very important pattern, not to block your resources by that. But it's not enough. And that's what I see that a lot of people are not really into. And I normally motivate that by telling a small story, which happened to me personally. So it's a nice way, actually. And it visualizes that very good. Who has used an airplane before? A safe question to ask. Okay, so you're familiar with that process. So it works like this. You book a ticket. Then you get an invitation via email 24 hours before the flight. Please check in. Then you click on the link. You select a seat. Then you pay money for British Airways for selecting a seat. And then after that, you click on Check Me In. And then you have another button where you say, Send me the boarding pass. Right? Probably know that. I did that for a trip to London, actually, last year. With Eurowings. I'm from Germany, that's why it's a German website. But it basically said when I clicked on the button to send me the boarding pass, hey, there was an arrow sending you the boarding pass. Okay. I imagine it like, we don't have Eurowings as a customer, so I don't know for them, but I know other customers who work a bit like this. And I imagine it to happen like, okay, I have the web UI, I have the check-in microservice possibly, and this will probably use other services in order to fulfill what it needs to do. For example, the barcode generator, this nice little 3D barcode is probably an own component, an own microservice. It's probably the output management because you can still get a PDF which you print out. Actually, that was my favorite one from British Airways. You can still fax the boarding pass. That's awesome. I just didn't have my fax machine with me. But these are other microservices it uses, right? And I think there was probably a problem down there, probably the barcode generation. Okay, we said we have to accept that. Failure will be normal in these distributed systems, so we have to accept that. That's not the problem. The problem is, and they had some kind of circuit breaking, probably not a circuit breaker, but they had capabilities in order to prevent that this takes down the whole site, which is not always the case. I start to collect screenshots from airlines, actually. Which is a cool hobby. I can totally recommend that because every time you get an error message, you're kind of happy that you get it, which is a weird thing, but it's cool to work. And this is actually from United Airlines. My flight back from New York was that. And the same thing. It was really, you cannot see it here, but I hit this send me the boarding pass button, and this is what I got. That's when you don't have this kind of circuit breaking at all. That's the worst thing that can happen. So they didn't have that, but they still had the error down there. And what they did is they transported that error really back to me as a user. Like, totally give that up the chain until the last possible moment, which is me. What can I do? What would you do? Yes, it's normally a safe question for developers. I mean, have you tried to turn it off and on again? So I retried it, obviously. You hit F5 or you just click the button again, but that didn't change the thing. So I waited like a couple of minutes, retried it, didn't work. So I created a calendar entry in my Outlook for 4 hours later, I think, to send me the boarding pass again. And that's something I call a stateful retry. So I retried it, but 5 minutes was not enough. And then I know my memory, my brain forgets about these things. So I make me something persistent which reminds me of doing that. That's a stateful retry. And it's actually a very bad design that I, as a user here, have to do this. That's a bad design. The best part of that story, and it's really true, it was my onwards flight from London on this trip was with EasyJet. And I got the same thing. They have a different error message. That's actually a better error message. They say, we're having, I'm reading that, it's possibly too slow for you, too small for you. We're having some technical difficulties at the moment. Okay, I recognize that. Please log on again via EasyJet. Okay, retry it. If that doesn't work, please try again in 5 minutes. Increase the interval. And the best part, that's really the best part, my favorite. We do actively monitor our site. We'll be working to resolve the issue. There's no need to call. It's your problem. Yeah? Take care of it yourself. We don't care. Okay, they don't say we don't care. But it seems to be a pattern with airlines that the check-in is really brittle sometimes. The booking is better. They still want to have the money, I guess. But I'm really happy that the aviation industry is good in flying. They're not really good at that. But, I mean, if they have a technical glitch, it's okay. I respect that. It's a distributed system. It will happen. But they should take it like, hey, we have an error. Yeah, that's our problem. Oh, we are sorry. We're taking care of that ourselves. Don't bother with it. And we send you the boarding pass on time. It's asynchronous anyway. I get an email or an SMS with that. I don't need it synchronous. I need the promise that they send it on time. They have like 20 hours for that or whatever. They should do that themselves. So they should do what I call the stateful retry down the line. For example, in this case, the check-in component could do that. Right? And then you don't have to transport the error all the way back. And I, as a user, don't see it all the time. And by the way, I'm using the example from the user, the human here, because it's very easy to understand. But that's what we do in microservice architectures all the time. We're sending errors to other services, probably, which are the clients then, which they should never see. So you should handle the error as close to the source as it makes sense. Right? And then the thing is, you need that stateful retry, because if you promise to send the boarding pass, you probably should do it. That would be nice, actually. Otherwise, it would be even more horrible. You send it and, oh, no, probably not. And it has to survive a restart of the system, these kind of things. So it involves state. And that's the reason why I see a lot of projects backing away from that idea and saying, okay, no, but now I have to handle state. I mean, we're currently in a world where everybody says, okay, we want to get stateless. And now that's state. It's actually not that hard to save state. It's 2018. We have a couple of ways of saving state, and I normally call it persistent things. So whatever you have, it could be a document store, it could be a database table, it could be an entity, it could be a persistent actor if you fancy it. I don't care. But it's something you manage yourself. It's actually easy to do, but what the most projects really sense, and that's true, is that this is not the end of it. Now, when you store it, you have to have, for example, a scheduler in order to do the retry. You have to have a monitoring. If that retry doesn't go through, somebody needs to get an incident, gets information that he has to look into that and these kind of things. So it's normally not easy, and you get a lot of additional things you have to do. And that's why a lot of people back away from that, which is actually true. If you just do a database table, you have to do a lot of things. Versioning is a good example. If you want to change the check-in procedure and you have pending basically processes that still have to send a boarding pass, you have to think about if that is a conflict, if you redeploy a change. So that's a hard thing. So there are easy ways of managing that, and they're actually quite known. So these are normally like state machines, or normally nowadays called workflow engines. But the thing is, whenever I propose that, people start thinking of, oh no, this is that BPM from the past, that these like awful, huge things, very unhandy, very proprietary from whatever, IBM and co. And as a developer, that's horrible to use. Normally call it death by properties panel, because you have to click through a lot of things, and that's not what I don't want to use. True, but that's not the case anymore. So if you look at the workflow engine market, that's currently really interesting. By definition, I basically look at the workflow engine market all my professional life at the moment. But there's a lot of things going on. So, for example, if you look at the cloud market, all the cloud vendors are doing some own workflow engines. Like AWS does step function, Azure does durable functions, Google does something with productizing Apache Airflow. So there are a lot of things going on. So it really shows that there is a problem to solve. Then we have the Silicon Valley companies like Uber did Cadence, or Netflix did Conductor, or Airbnb did Apache Airflow. So they are reinventing some kind of workflow engines there, which is interesting to observe because they have that kind of problem to solve. They're very actually opinionated for the environment. So for example, Uber and Cadence is Go and Cassandra. If you're not running Go and Cassandra, it might not be for you. But then there are still a lot of like really lightweight open source workflow engines out there, and there are a couple of them actually. So for today, by coincidence, I used the one we do. That's the open source one from Camunda, but there are others which are really comparable in the way I present them today. For me, the main idea is they are really lightweight, and you can really use them for these kind of tiny problems. I will show that in a minute. And you can also do that at scale. I'm not talking about that today at all, but we're currently running an R&D project, and I know one or two other projects going into the direction of horizontal scalability for workflow engines. So we have customers running like 20 or 30,000 requests per second. And yes, you can use workflow engines for these kind of scenarios, not like, let's say, the traditional ones, but there are things emerging. But anyhow, today, by coincidence, Camunda, and this is how it looks. And I want to give you just an impression of basically the complexity involved. So we use version 3. By the way, at least the front rows probably see that we have up to version 7. So there are a couple of versions for homework. Okay, you can already prepare mentally for that. Don't go through all of them. But now we are with version 3. So what did I change? The first thing is I auto-wire a workflow engine. In this case, Spring Boot, it's very easy because there's Spring Boot starter. It starts up that state machine, and it's auto-wired. Nothing more to do. It's a main dependency in this. And then I define the flow, like the model of the workflow. And in this case, I'm using a so-called BPMN. It's an ISO standard for defining this flow. It's a language, basically. Does anybody know BPMN by coincidence? A couple of you, okay. I create an executable process. I start here. The first thing I do is I call a so-called service where it can attach code. And in this case, it's the so-called Stripe adapter. The Stripe adapter, because I'm in Spring Boot, it's a Spring Bean. And then this is basically, it implements an interface. And then the code I already have, I didn't change the code at all, is moved to that class. Okay, so the only thing I do is I move it to that own Spring Bean, and then I can attach it to the workflow, and then I'm basically done. And what's the advantage? The advantage is now I have a state machine, and the state machine is persistent, and I can do stuff like, for example, the retry. And this is an ISO standard to define that I want to do 3 retimes with a delay of period time 1 minute. But it can do fancy stuff there. It could wait for like 4 hours before the flight or whatever. So you can do a lot of cool stuff. And then you deploy that workflow model. It's versioned in the background by the engine. And that's it. And then when you charge the credit card, you don't charge it directly, but you start a workflow instance. Okay, this is just like a 1 line of code thing. And now the behavior changes. And let's go back to that. So the Stripe service is still slow. Oh, sorry, not PowerPoint. And we go to V3. And now I hit the send button. What you can see is the first is I get a response pretty quickly in my REST service. I make that a bit bigger probably. You will see the charge is still slow, and you probably saw an exception passing by because Hystrix is still open. What's interesting is I switched the response code in my HTTP request to 202 accepted. So I don't say, okay, here's your response, but I say, I got it. I take care. Asynchronously. I will call you back, basically. And that's much better behavior here, right? And what happens in the background is that, oh, haven't started my browser, let's do that. These kind of tools normally have a console, so I can look into what's going on. So you can see, in our case, that's called Cockpit. So I can see that I currently have a running instance waiting for the Stripe thing. So this will be retried for a time, and I have, like, I can look into that. And I can see what's currently waiting there. So that's cool. But now, normally the next discussion I'm jumping into is like, okay, but you changed the behavior to asynchronous. I want to have like a synchronous response in order to, for example, show the PDF directly in the browser that the people can print their boarding passes. By the way, nobody wants to print the boarding pass. My mother probably does. I never. Most people don't want to print that. So that's a discussion on its own. But this is normally what you get. And the cool thing, and that's V4, and that's homework to check the code. I hit the button. It's still 202 accepted. Okay, but fair. The Stripe service is still slow. Let's let the Stripe service behave normal. What happens is that I'm going back to 200 OK. So it's synchronous. And it's actually not slow. It's not slow just because I use this kind of technology underneath, but I have now the state machine which could do something whenever there is a problem. And that's actually a very, very desirable behavior from my point of view. You can switch to asynchronicity completely. That's also a possibility. But I see still most people using these kind of REST architectures and want to have a synchronous result. Then you can do this kind of thing. Okay, awesome. So that was, also I wanted to give you an impression of the, like, what do you have to do in order to get it running? It's not much, actually. But now you have that state machine, and you can do cool stuff with it. You can, it's persistent, so it's stored really on disk. And restart the service, it will still be there. It will be retried. By the way, and that's an important thing, actually. If you do this kind of retrying, and you will do retrying in microservice architectures, there's no way around retrying, actually. Then you have to care about idempotency. And that's actually even more important than circuit breakers. So if you only want to remember one thing of that talk, then it's that idempotency is super, super important. Because you will have retries, and that means sometimes you will have calls that are made twice at your service. And you cannot really avoid that in distributed systems, so you have to care. Idempotency means if it's called twice, it's not a problem, right? You can call it twice. You can basically also think about idempotency again from a consumer perspective. You probably remember times, it's a bit gone nowadays, it got better, but I still have a lot of these sites. Do you know that when you enter the credit card details and click on pay, and then you get this like loading thing where it says, don't close the page, don't reload the page. Weird things will happen if you reload the page. And I'm traveling a lot, so what I normally do is I do this kind of shopping in the train and with a leaky Wi-Fi. And that means when you do this and you see that and you see the tunnel there, it's like, whoa, God, for God's sake, do that faster. What happens? And the other part of my mind normally is constantly saying, press F5, I want to know what's happening, press F5. But it's like, okay, but that's costing money probably. That's bad design, that's really bad design. It should be really different. You could do it in a way that, hey, you want to give us money? Awesome. We take care that this is really like a good experience for you. And you can press F5 as long as you want to. You can close the browser, reopen it, and we will do it for you. That's probably more tricky to do, but technically that's possible. And normally you do strategies like generating like correlation IDs as soon as possible and sending them along so you can spot like duplicate calls. It's not totally easy, but it's really important to make sure you have this in distributed systems. It's so important that I invented my own metaphor for that. It took me a while. And it's zucchini. And the good question would be, why a zucchini? And the explanation is very easy. I had a vegan part in my life. So before I got kids, you can do these kind of things. So with my wife, we had like 4 or 5 months of eating vegan. And there's an awesome dish where you slice the zucchini into noodles. There's a special slicer, and then you get kind of noodles out of the zucchini, and then you add some sauce, and it's really good. It's really good. I totally recommend the recipe. And the good thing, and it's even written in the cookbook, you can eat as much as you want, because zucchini, I mean, you don't grow fat, it's not unhealthy, you can really literally eat as much as you want. So if you forgot, if you ate your plate of zucchini, you just eat another one. So eating zucchini is totally idempotent. Eating pasta is not, right? So keep that in mind. Keep that. It's really important. Keep that in mind, right? So your service should be more like a healthy zucchini, right? So, but we are not at the end. And this is, I mean, it's a very easy example, but you can do a lot of things with it. So if we say we do that retrying, right? So we, and this is by BPMN, by the way. I defined it in code earlier on, but you can also use a graphical modeler if you fancy it. So I start here. I charge the credit card. I do the retrying. There might be a certain point in time where I say, okay, it doesn't work. It might be like a timeout, or it might be I retried it for 10 times. It doesn't work. There's a point in time where I say, no, it doesn't go through, and I raise like a payment failed. So I send something, okay, we cannot retrieve the payment, cancel the order or whatever. Okay, that's very realistic to do. Now, we have one problem. We're still in a distributed system, and there's one characteristic which is really ugly in distributed systems, and this is that if you do a network communication, and let's assume you're doing REST calls for a second. So if you have a client, and that does a REST call to a provider, and you get a network error, you have no idea if that really like was on the way to the provider, if it reached the provider and the provider exploded, and that could be like before he committed the transaction or after, or if he did everything correct and the response got lost in the network. You have no idea what happened. And it's the same thing if you're using asynchronous communication. If you're sending a message and don't get a response back, you have no idea. There's no way of really knowing this. So you have to take care of this. There are situations where you can ignore that, so you have no idea, okay, I don't care. But in payment, definitely not, right? So in payment, you have to think about it, because you probably have charged the credit card. If the credit card charging is not idempotent, you probably have charged it multiple times. And then you say, oh, but we don't deliver the order. That's not a good experience, I think. The strategies vary. So you could do something like I refund the charge later on, or I ask the credit card if it charged something. Okay, that depends a bit on what you do exactly, but the important thing is you have to do it. You can do it asynchronous later on, so that was by intention that I said I raise the payment failed first, and then I take my time in order to refund. That's normally not time critical, because it has to be like stateful again, because probably if the credit card charging was not very reliable with the network, the refunding is not as well. So I have to retry again. So you see this kind of complexity emerging there. Okay. And I use BPMN, and I'm actually a big fan of BPMN. I wrote a book about it, but it's more like because I'm a fan. No, not now I have to be a fan because I have that book. So it's an ISO standard, and it's really widespread, so worldwide. It's very common, and the cool thing is you can directly execute it. That's what we already saw. It's a very mature language. If you compare it to all the emerging workflow engines like AWS, step function, and so on and so forth, the language is much more mature. You can do much more cool stuff with it. I'll show a couple of things in a minute. And it's easy to understand for different stakeholders. So even if you haven't known it before, it's probably easy to read these kind of models. And we make that observation with a lot of projects. So different stakeholders, operations, business folks probably even, and also developers are really capable of reading that without really learning it beforehand. And this, for example, in operations, it's very easy to show. So if you have this kind of charging the credit card there, and you retry it and whatever, then you probably have errors piling up for whatever reason, and then you want to dive into that, seeing some context, seeing the data, the payload, probably retry it from there as an operator, or you want to see statistics, what's going on in the system, what's the current path, and so on and so forth. So you gain a lot of these kind of things by using a language as BPMN, and that's much more powerful than, this is, for example, what's possible in step functions, and this is it. They don't have a lot of these concepts there. So if you compare this, and that's actually, it bothers me a bit that all the new workflow engines reinvent the language, actually. I understand that they do new technology, that's cool, but I think the language is mature. They should reuse the language. It just has a bad reputation because that BPM of the past. But that's the past, I mean, it's still a good language. Anyway, probably a personal thing. Important thing is that I run the workflow engine here as part of the service, like I did with the circuit breaker. So it doesn't mean that I have to run anything central, right? So, and just in this case was the library as part of the Spring Boot service. Same thing would be in the check-in component. I would just add it there. And then I have the state up there. I can do the stateful retries, and I can make sure that I don't have to make that Outlook calendar entry, because they do the stateful retrying, and you have the notion of time, so you can do stuff like, if it's too late, if that takes too long, I have a plan B, for example. I could apologize to the customer, sending him an email, go to the desk. We cannot sort it out. It would be better than the current behavior, I mean. Anyhow, if you're interested in that, I'm not concentrating on architectures, how to run a workflow engine. I blogged about that. You have the slides available later on, so you have the links. And what I did today, basically, I just embedded some kind of workflow engine in Spring Boot. And then if I have multiple microservices, they probably run their own engine. You can do the same thing also with WebSphere or WebLogic or Wildfly or whatever, if you still want to do that. If you're not in Java, if you want to have other languages, you can just connect remotely via REST API. That's also possible. So there are quite a possibilities out there. So we talked about synchronous communication, and I already said that I don't believe that I always need a synchronous response business-wise. But you can have it. So that's what I did earlier, right? I did 200 OK if everything is fine, 202 accepted if not, and then I talk to you later on. So it's potentially long-running. But I discuss that so often that the people say, the last time I had a really huge discussion about that was for ticketing, for train tickets, where they said they need the ticket in the browser right away for the people to print. And I still believe that's not the case. I mean, if I can choose between a synchronous error message and an asynchronous result, like the PDF as an email, like 2 minutes later, I know what I know better or what I like better as a customer. And what I normally pull up is this quote. I love that quote, actually, from Todd Montgomery, Martin Thompson. They're doing like high-frequency trading messaging systems. So they're quite a thing in the distributed systems world. They said, synchronous communication is the crystal meth of distributed programming. It's kind of, I mean, synchronous calls, that's why we love them. REST call, it looks, if I look at the Java code I heard earlier, it looks like a local method call. But it's not a local method call. It is not. It's totally not. And we should get aware of that, and people start getting aware of that, but then they still say, yeah, but it's so easy. I know it's not really good for me. I do it the last time. Tomorrow it's better. Next project. And I think we should really think about that behavior. I think a bit of asynchronism is really good for the architecture. The changes a bit, but not that much actually. But for example, if I look at that example, if I have the check-in service and it uses the barcode generation, sends a message, then it still has to do something like monitoring if it gets a response. Because I don't want to do that. I don't want to have the Outlook calendar entry. The check-in should do that. And that means it has to monitor timeouts, that's stateful again. And then probably it even do something like this, where it says, okay, I send out something, and then I wait for the barcode. And now I really keep track of that. If that doesn't happen within a certain time, I do a retry in the asynchronous world. I resend the command, or I ask, or I do something, I escalate. And whenever this, for example, doesn't happen within a certain time frame, I can really do a plan B again. So that's very powerful, actually, to have this long-running capability. Cool. So then you probably have to care about timeouts if you're asynchronous. But the other things don't change much. Talking about asynchronicity, who uses a message bus here? Just because I'm curious personally. Rabbit? Kafka? Okay, and the else thing, what else? JMS thingy, whatever. Okay, from the people using a message bus, who has no problems operating the message bus? One? Oh, two. Normally it's one. Two is good. To be fair, it's relatively safe as a speaker to ask no problems question. Nobody has no problems. But what I see at a lot of customers operating these kind of tools is they are lacking certain tooling around it. So if you use messaging, you have probably dead messages. A dead message is if you cannot process the message. So you deliver it, it cannot be processed, there's an exception. You don't have like a client waiting. So you have to have a way to handle the exception, and that means you put it in a dead letter queue. And somebody has to monitor that, and then you look into that, that's the operator probably, and you want to see the data attached, the payload. You want to probably see where the message came from. You want to see as much context as possible in order to understand why this message ended up in the dead letter queue. And then you need capabilities in order to probably to tune the payload, to fix it, and to redeliver the message. Everybody needs that, but the tooling is not there. If you're having these kind of default tools, they don't have that. So everybody builds homegrown message hospitals, it's normally called. And that's effort. That's what a lot of people don't like to do. And for me, it's a surprise that it's still like this, but it's still like this. I hope that gets improved pretty soon. And the interesting observation is that we have now customers, that's probably my biased worldview, but we have customers going into a direction which is really interesting. So you could use the workflow engine in a way where you say, okay, I now hit like a service task and I call actively a REST service. That's what I did earlier on. Or in asynchronous, you would actively push a message to a queue. That's kind of a push model. But you can use the whole engine in a kind of a pull model. And that means you say, okay, the workflow engine is kind of a work distribution, a topic on its own, a queue on its own. And the service says, okay, I can do that service task, and I fetch the work, right? Technically very easy. I'll show that in a minute. And then you basically can replace, for parts at least, this kind of messaging infrastructure where you say, okay, a service still owns the process model, so that's important, ownership of the model, deploys it to the workflow engine, but then I have the services subscribing for certain topics there, and then the workflow engine distributes that thing. And the advantage is that you gain that operation tooling. Right? You see exactly the context, what was my workflow, where it came from, what were the steps, what's the payload, how does that evolve, and you have a lot of possibilities to do something with that. That's very interesting, actually. And I never really proposed that as a best practice architecture, because there are a lot of discussions around, is that a good idea or not, but I see it being applied quite successfully. It also solves the second thing, which is also interesting to think about. Not going into details here, but you've probably heard of the thundering herd problem. I said retries earlier on. So if you have REST calls and you're doing retries, if a system, a component goes down, it normally means when you bring it back up, it's really getting a lot of retries because a lot of retries have piled up and now making some kind of denial of service attacks towards that new coming up service. That's the thundering herd problem. It got very famous. Actually, that's my favorite outage of the thundering herd problem. You probably remember it, 2015, there was an outage of a whole region of AWS for 5 hours. A whole region. That affected a lot of tools like Netflix. I had this with Trello at that time, or Airbnb, Tinder, if you like. There are a lot of things which were affected by that outage. That's a huge thing. AWS complete region, 5 hours. I actually, when I looked it up, I liked that one because I don't know why they put that picture under that headline. That's kind of a weird thing. But I loved it, actually. But the interesting part, you cannot read it, but if you get the slides, look it up. There's a link where Amazon explains what happened. And it actually was the thundering herd problem. They had a small, the root cause is not that important. Somebody shut something down, they had a network problem there, and then they had a lot of services going into retry mode. And when they brought up the thing again around at 3, and basically, the whole infrastructure was overwhelmed with these kind of retries, bringing it down again. And that was quite a huge thing. And that's a thundering herd problem. And you get rid of it a bit by asynchronicity, but also by this kind of work distribution. So that's basically the price you have to pay for retrying. You have to think about these kind of things. Awesome. That gives me 10 minutes, which is not much, for my favorite topic, consistency. I have an own talk on that, lost in transactions. There are a couple of recordings on that, if you like. So the basic idea is we have the distributed systems. We don't have transactions, ACID transactions in distributed systems. So you cannot do something like begin transaction, do A, do B, commit, or roll back. It doesn't work in distributed systems. If you, who is using who knows of two-phase commit, XA transactions, three-phase commit? A couple. Okay. 30%. Who uses that in production? A couple. Who's happy with that? Oh, I haven't had a no problems question. It was happy. And there's an awesome paper by Pat Helland. I'm a big Pat Helland fan. He worked at Amazon at that time, and he wrote Life Beyond Distributed Transactions. And he explains very well why distributed transactions are a bad idea, why they don't scale, why they pose a lot of problems. So basically, I would sum it up in the quote from Pat Helland, which is really good for that. Grown-ups don't use distributed transactions. Don't do that in a relatively complex distributed systems. It will simply not work. Okay? But we still have the requirement. We have the requirement of doing 2 or 3 things in an all or nothing semantics. We still have that. So how can we tackle that? And one approach, not the only, in the other talk I talk about different ones, but a very important approach is so-called compensation, or the saga pattern. Not sure if you heard about that. So compensation goes like this in BPMN. So I started the workflow here, for example, and I extended it by first I retrieve some money from a customer credit account. If that was not sufficient, I charge his credit card. And then if I have an error while charging the credit card, I have to make sure that I also refund his customer credit, which I already deducted. Right? This is about eventual consistency, because here in the middle, I already deducted stuff, but I haven't yet made his payment successful. So that's kind of an inconsistent state in between. I have to live with that, but I have to make sure whenever I have the failure, I undo it. And that's what compensation is about, undoing things semantically. And BPMN supports that in a way that I say, here, I want to trigger the compensation, and then for every activity which has this compensation activity configured, this one is called automatically by the engine. Okay? So this is what a workflow engine can do, again, stateful and reliable there. So that's a very important pattern. Yeah, that's what I said. Yes. Let's quickly look at that, really quickly. So what I have in the code, we are jumping directly to V6. V6, I have the workflow model. This time I did it graphically. So that's the one you know from the slide, right? This is where I can model it. Then I deployed that, and I have V6. So my Stripe fake service is behaving normal. I'm calling v6. I'm getting a 202 accepted. Why is that? So we look at the workflow operating tool. We're looking into v6. Okay, there is some instance waiting for deducting the customer credit, and that's actually one instance. So if I do it again, I see that there are 2 instances currently waiting. So why is that? Because I wanted to show you what I mean with the work distribution quickly. So the deduct existing customer credit has configured a so-called topic. That's probably not readable. It's just a name, like a queue name. And then I can have clients asking for work. And currently, that could be like a second microservice, which asking for the work to do. And this is not running at the moment. That's why it's stuck there and waiting for the service to become available. And I actually did that service. I programmed that in JavaScript. I thought this would be like, oh, awesome, I see JavaScript today. But it's I also have it in Java, but I give you the JavaScript version of it. There we are. So let's go there. The code is actually pretty easy. It's even understandable in JavaScript. So what I basically do is I connect to the REST API of the engine and say, hey, I want to subscribe to that topic. And then whenever you have something to do, call that function, and the function does business logic, and then it calls back and says, hey, I'm done. Okay, that's it. So that's the whole code I need. And if I run that worker, and I have it also in Java or Golang, or that actually doesn't matter. If I run it, I see that it now processes the 2 customer credit requests I had. So if I go back, I see that they are basically gone. So they are now history because they successfully went through. Okay, and now everything is up and running. So I switch back to 200 here, right? And not slow, that's the next thing. Again, it's not slow because you use these kind of architectures. And I should have, yes, sometimes I have 500, that's by intention because I want to trigger like payment errors. And if I do that a couple of times, I should see that I have like some of them basically going down the failure route and then restoring the credit. So if you play around with that, and then you see also a couple of statistics. If you play around with that, you get an idea how the compensation is working. That's the idea. The code is there. So if you fancy, just go on GitHub and get it running. So now I use compensation, which is, from my perspective, very important in distributed systems. The most common problem, again, is that the service provider has to offer it. If you have legacy systems, they often don't provide the compensation method, the undo, because they never thought about that. If you want to be a good citizen in distributed systems and you do a service, make sure it's idempotent, make sure it offers the right compensation method. If you do that, life for your peers will be so much easier in the future. And if you have to talk to a service, make sure you have these kind of patterns in mind, and then you will also be able to work around these pitfalls, basically. A lot of things are stateful. That's something you have to get used to, but that's not a big problem. If you're actually fancying event-driven architectures. I haven't talked about event-driven here today because it's the limitation of time, but I have the same example also running in a completely event-driven way, choreographed and orchestrated. There are a lot of interesting things you can look at in there. So if you fancy that, it's also on GitHub, or you can ask me later on. I mean, I'm still here the whole day, so I'm happy to walk you through. One important thought, and that's one of the last slides, but also one of the most important thoughts here, just to make it clear. I had that payment workflows thing, right? I see these kind of workflows as implementation detail of the payment service. So the outside world doesn't know that, doesn't have to know that. Other services might have workflows as well. For example, the order service might have like an orchestration workflow where it says, okay, first I want to retrieve the payment. No details about payment at all, just commanding it to do it and waiting for the response and probably monitoring a timeout there. No details. The details are on payment. So this is really a distributed view of the responsibilities of these kind of workflows. So it's not central. It's nothing like that. And that's a very powerful view of that. And if you want to implement it like hard-coded in payment, if that's a good tool of choice, it's fine. If you want to use tool A for that, tool B for that, that's fine. So that actually doesn't matter. The idea is more important here. If you wonder if that's really reality, yeah, we have, for example, Zalando as a customer. They're shipping every order worldwide over our platform, and they're doing it like this. They had a meetup last year where they showed that they're using Kafka underneath, doing it more or less like I I described here. So that's pretty cool. They're doing quite a lot. Awesome. So recap, the summary. So be aware of that complexity. I think that's the most important thing. I'm still working on that, actually, with a lot of teams, that they're really aware they're entering distributed systems. That has a lot of complexity. And then you need to know the right strategy. So, for example, circuit breaking, really important. Everything discussed about service mesh, really important. But this is one side of the coin. The other part is stateful, and the stateful part is normally not moved away in a service mesh. It's kind of a business logic. How long do you want to wait? What happens if the timeout happens? What's the compensating activity, and so on and so forth. And you have to have answers to these kind of stateful problems. And that will be good. And then you probably use the right tools, and then it's a lot of fun. Okay, awesome. That's all I have. This is there are the links. I hope that was enjoyable, and probably also gave you a couple of informations. If you have any questions, I'm there over at the booth. Thank you for coming. Have a nice day at JAX.